Example 6, find the domain of each function and sketch the graph. I have g of x is equal to 2 plus log base 5 of x. Any log, regardless of the base, is before the plus 2, is going to cross through the point 1, 0. And that's because when the exponent is 0, I'm going to get 1. 1 is my solution to the exponential of this. All right, so if I look at the very basic version of a log function, it looks like this. Adding 2 on the outside just means we're going to go up 2 spaces, so every point moves up 2. My asymptote is going to stay where it's at, and that is my graph. Now, similarly for b, I'm going to have that same passing through 1, 0 point with my asymptote at 0. But here I have a minus 3 on the inside. That means we're going to move right 3 spaces. 1, 2, 3. Here's my new point. And also my asymptote is going to move 1, 2, 3 spaces as well. We also have something called the common log, and this is specifically when we're talking about base 10. We don't have to write the number 10. It's understood to be there, and that's that log button you'll see on your graphing calculator. So we can use the calculator to approximate these values. So let's see, we want 0.01, 0.1, 0.5. Okay, let's take a look at these. All right, so we want the log, so we're just going to hit the log button of 0.01. That's -2. We want log of 0.1, log of 0.5. So let's see, -2, -1, -0.3, -2, -1, -0.3. We want 1, 4, 5, and 10. Log of 1, log of 4, log of 5, and log of 10. So we're going to get 0, 0.6, 0.7, and 1. 0, 0.6, 0.7, and 1. And we can put a quick sketch here. So we have easy numbers. Let's go with 10, 1. And we have, let's see, 5 would be here. So we have 1, 0, and something about there-ish. And those numbers are getting lower and lower. So this is going to be a pretty flat one with an asymptote at 0. All right. And if we needed, our domain here would be that x is greater than 0, because we're just using really our asymptote to help us with that domain. All right, the natural log. So the natural log is specifically when we're talking about base e. But instead of writing log base e of x, we just write ln of x. ln stands for logarithmus naturalis, just Latin for the natural log. It follows all the same rules. So if I take the natural log of 1, we're going to get 0, and that really just means e to the 0 power is 1. Natural log of e, we're going to get 1. That means e to the first is equal to e. Natural log of e to the x is equal to x. That means e to the x equals e to the x. And e to the natural log of x equals x. If I switch that to a log function, that would be log base e, or ln, of x is going to equal natural log of x, which it does. All right, so we can use these properties to help us evaluate here. So we have the natural log of e to the 8th power. Remember, that just means it's going to equal 8. Here I have the natural log of 1 over e squared. We can rewrite this and say that's really e to some power, we don't know what, is equal to 1 over e squared. But I can think of that as e to the -2nd, which means my exponent here is -2. Now the natural log of 5 is not something I can do by hand, so we can use our calculator. There is a special natural log button. It's right under the log button, ln of 5. And we're going to get about 1.609. And lastly, we want to find the domain of this function, natural log of 4 minus x squared. Now think about this. This is going to equal some exponent, right? So this really means e to some exponent is going to equal 4 minus x squared, if I think about this more exponentially. When I raise e to any power, I'm never going to get anything negative because e is positive to begin with. So this can't be negative. I'm also never going to get 0. So this can't be 0. And that's because e has some value. Even e to the 0 power is going to give me 1. E to a negative power is just going to be 1 over e to something. So I'm never going to get 0 there. So it can't be negative, it can't be 0. That means whatever I'm taking the log or the natural log of has to be greater than 0. So now we can just solve this. I'll subtract the 4. Remember, when I divide by the negative, I'm going to switch the symbol. And then when I square root, I do get plus or minus. So x is less than 2, but greater than negative 2. And I could test to just double check. If I plugged in x was 0, 4 minus 0 squared, that works, no problem. And when I plug in the negative 2 or the positive 2, I'm going to get 0. So that makes sense for my endpoint.